All right, everybody. Welcome to Chapter 7 here. Like I've said in class, this is going to be relatively just contending with two different days of this chapter, really. It's going to be today, and our next lecture video, number 2, will be really the beginning and then the end of Chapter 7. So it's a pretty quick one. So let's buckle in here and talk about Chapter 7, which is titled Chemical Reactions, right? So, guys, the entire first half of the school year, basically September through December, we've been focusing on building a lot of the building blocks necessary to really talk about some real chemistry, right? And a lot of the second half of the school year going into, January here, February, March, all the way through June, or really May, I guess, focuses on this concept here, chemical reactions, right? Because chemistry is really just all about all of these different substances we've been learning about, whether they're ionic or covalent or wherever, and then reacting, right? That's the main goal that we've been trying to focus on here all throughout the first half of the school year, right? So we've been talking about all the things we need to talk now about chemical reactions. So let's do that. So in its most basic form, a chemical reaction is a process in which atoms of one substance are rearranged to form a different substance, right? So with this in mind, this idea that it's a process where atoms are essentially being rearranged to form new substances. This is all about what chemical reactions are all about, right? It's essence, right? All these beginning pieces over here, right? This compound that has a white and a black dot together, mixing with this single element on the left here, or on the right hand side here, on this gray dot. These things are reacting together to form totally new sets of compounds and substances on the right hand side, right? You've essentially swapped in the gray dot with the black dot, and now you've got this compound here, these two together, right? The white and the gray, and then the black dot all by itself over there, right? So you're rearranging the atoms of different substances to form totally new substances. That's kind of the goal here, right? So now, how do we talk about some evidences of, or some evidence of chemical reactions, right? This is going to kind of be a little bit of review from chapter 3, if you can remember, right? Chemical reactions are changes often occur with one or more of the following things happening, right? Maybe there's some kind of temperature change that occurs when this chemical change happens. There's energy release in some way, shape, or form, whether that's in the form of light, whether that's in the form of heat, or whether that's in the form of sound. There's some kind of energy being released in some way, shape, or form, right? And that will come as either light, heat, or sound, right? You're oftentimes going to see color changes occurring as well. That's a pretty basic one and pretty common piece of evidence of a chemical change. You might have some odor changes as well, right? You might have some smells that are going to be newer compared to the smells that were originating or that had originated from the previous substances, right? So when you mix things together, you might have a new odor arise from the new substances that are formed, right? And also another big one here is the formation of gases or solids, etc., right? So if you mix two things together, you might have some sort of gases forming, right? And vice versa, if you mix two things together, you might have some kind of solid pieces forming, etc., right? So the formation of almost like new substances that take on a different state of matter from the original states of matter, right? So if you mix two liquids together, and now suddenly you've got a solid coming from it, right? That's going to kind of give rise to a, hey, this is probably going to be a chemical reaction because that piece of evidence tells me I've mixed two liquids together, and now I have a solid. Well, where did that come from? Well, chemical reaction, okay? Now, of course, everything we do in this class in chemistry and really in science in general is always driven by making sure we can model things, right? Making sure to model something so we know how to talk about it and essentially how to showcase it, right? Well, that's exactly what a chemical equation is. It's a model and a way to show off exactly what kind of chemical reaction we're utilizing. It's a statement that uses chemical formulas to show the identity and relative amounts of substances involved in a reaction, okay? Uses chemical formulas to show the identity and relative amounts of substances involved in a reaction. In essence, guys, it's a sentence in the language of chemistry, right? And today's focus is going to really be on that idea and that ability to really start to translate some words from English into some words and phrases in chemistry, right? And we've kind of been doing that, right? We've kind of been building that repertoire of being able to speak in the language of chemistry by talking about ionic compounds, by talking about covalent molecules, right? And being able to name them from their formulas and vice versa, right? We've kind of been training ourselves to learn the words associated with this language of chemistry. And now with this idea of chemical equations, we're going to try and use those words to formulate sentences in chemistry, right? That's the main goal here. Now, Some key characteristics, and these are a couple words I've actually used a few minutes ago here, guys, right? When it comes to chemical equations, there are essentially two different sides to a chemical equation. The side on the left-hand side, when it comes to the equation, are what's known as your reactants. They are your starting substances, the things, quote unquote, that react, right? So if you've got two different reactants that are forming together and essentially reacting together, those are your starting substances, your reactants on the left-hand side of this statement, right? This sentence in chemistry, this chemical equation. The stuff on the right, however, are what are known as your products. They're going to be the things now on the right-hand side of your chemical equation, your sentence in chemistry. They are the substances that are formed during the reaction, the things that form after the fact, right? They are your resultant, your product, your end point, okay? So your reactants are what you start with, your products are what you end with. Your reactants react to form your product, your ending piece. Now, let's reaffirm some notation and chemical equations, right? A lot of this, guys, is going to be a straight up rip from chapter 3, right? A lot of these things you have all seen in the past, right? We know that whenever we see an S, an L, or a G, lowercase, all around some parentheses, right? We know that that S is going to be solid, that L is going to be liquid, and that G is going to be gas. And if we forgot it, that's okay. That's why we're reviewing it right now, right? We've also talked about this AQ in the past, right? This AQ here, gentlemen, that's known as an aqueous solution, right? It's when you've got some kind of substance that's been dissolved in water, right? So it's technically a liquid, right? But it's a little bit of an elevated liquid. It's got some liquids with some other components mixed into it, okay? Now, these other two pieces here are going to be the main center points for chemical reactions. You can think of these almost like a dividing line to help us associate what is a product from what a reactant is, right? And it exactly says that right here. So this single-sided arrow here, guys, this is what separates reactants from products. And we'll see how this gets utilized when we start to look at some actual chemical equations, right? Now, this second piece here, this almost like double-sided arrow here, right? One going to the left, one going to the right. It separates reactants and products in both directions, both the forward direction and the reverse direction here. I'm going to put a very solid pin in this idea of this double-sided reaction or this double-sided arrow here, guys, because we're going to talk all about this. This double-sided arrow is the premise for almost an entire chapter and a half later on this school year, right? So when we're talking and looking towards the spring, around like April, May, right, this double-sided arrow will come back and we'll be using it constantly. So I'm going to really just put a pin in this thing for right now and much more so just associate ourselves with this single-sided arrow for right now, okay? Now, this idea of words and skeleton equations. Now, skeleton equations are going to kind of help be the basis for how we actually put together an actual chemical equation. But we do that in a form to almost literally translate the English language to the language of chemistry or vice versa, right? It's almost like a sentence that you verbally will say when it comes to looking at a chemical equation, okay? So here's a sentence I'm giving you guys in English, okay? The words are as follows. Sodium metal plus water yields aqueous sodium hydroxide plus hydrogen gas. Okay, those are all words that you would normally say in the language of English. Okay, however, all of these words, guys, put together in a sentence mean something in the language of chemistry. They are essentially a skeleton equation to help put together. They're the words in English you would say to actually formulate your chemical equation. Okay, that's a reference to the chemical reaction that's taking place, right? It's literally talking about sodium as a metal reacting with water, which yields or essentially is producing this substance known as sodium hydroxide and this other substance here called hydrogen gas. Now, if I were to translate this, guys, from the language of English to the language of chemistry, this is exactly what it would look like. I don't know what's happening on my screen. There we go. Okay, now this is what this sentence looks like in the language of chemistry, right? Think of yourselves, guys, like you're in your language class, right? We're talking Spanish, French, German, right? Whatever language class you're in right now, guys, it's almost like you're being asked to translate from English to Spanish, English to French, English to German, right? But in this case here, guys, that secondary and that new language here is in fact the language of chemistry, right? So what we're doing here is quite literally translating word for word from English to chemistry. We know sodium exists as Na. It's atomic symbol, right? We know sodium, metal, well, if it's a metal, guys, it's of course going to mean it's a solid. So we have an S in parentheses to let us know this sodium is in fact in a state of matter of solid. Plus water, well, plus sign means I have to write a plus sign. Water, We know water, guys, is H2O, and water is going to always exist as a liquid. So we have to make sure that this water has an L in parentheses to represent the fact that it is, of course, a liquid. Yields. Now this word yields here, guys, this word yield is going to be where we place in this single-sided arrow here, right? It tells us that, hey, these pieces on the left here, these reactants, sodium, metal, and water, are reacting to yield these new substances on the right. Aqueous, sodium hydroxide. We know sodium hydroxide is NaOH with that polyatomic ion there, OH. We know it's aqueous, so we use the AQ in parentheses because it literally says the word aqueous. Plus, another plus sign right here, hydrogen gas. We know hydrogen gas needs to be an H2, guys, because it's one of those diatomic molecules, right? There's those 7 diatomic molecules that are on the periodic table. And again, the fact that it says gas, guys, means, well, we just put a G in parentheses on the right-hand side of these formulas. Right? So, guys, all this is a direct translation from the language of English to the language of chemistry. That's all that's happening here, right? So how do we do that? It's very, very, very easy, okay? My reference would be to say, hey, write all the symbols and the formulas first, right? Write all the symbols of your NAs, your H2Os, your NaOHs, your H2s. Write those first, right? Get those out of the way so you can do your direct translations, right? Then include the states of matter associated with each one, right? Making sure you know what your Na, your sodium, is solid. Your H2O is liquid. Your NaOH, right? Your hydroxide. Your sodium hydroxide is an aqueous solution, and that your hydrogen is a gas with a G there, right? Include those states of matter. And then lastly, oh, it's missing here. But lastly, add your pluses and your arrow to boot, okay? Add your pluses and your arrows to add in there, okay? Now, here are a couple of things to memorize in terms of direct translations, right? Conveniently enough, I just mentioned, guys, all of the different diatomic molecules. There are 7 of them. Well, here they are right here, okay? Here's your 7 diatomic molecules, right? Every single molecule here that when you read the word, it's going to instantly translate to the diatomic version of it, right? So if you read the word hydrogen, guys, you're not just getting H, you're getting H2. If you read the word nitrogen, you're not just getting N, you're getting N2. Same with oxygen, O2, fluorine, F2, chlorine, Cl2, bromine, Br2, iodine, I2, right? These are going to all be, essentially direct translations from the language of English to now the language of chemistry here, right? Ammonia, that's the common name for NH3, although you'd want to name that naturally, right? Nitrogen trihydride, right? That would be technically the correct name for it, right? But just like water is the common name for H2O, ammonia is the common name for NH3, okay? If you ever read these words in English, precipitate, powder, or chunk, right? That's going to be representative of a solid. So make sure you use the word solid or even put the S in parentheses. If you read the words solution, mixture with water, etc., right? Anything similar to that, you're going to want to use that word aqueous or the AQ in parentheses. And then if you read that word vapor, guys, vapor is just another form of gas, right? So of course, we're going to want to use that letter G in parentheses there, right? So again, these are all just kind of memorizing different ways that we can translate from English to chemistry, right? Now, coefficients. The very, very last thing I want to talk about, guys, are coefficients. Now, what are they? You might have heard them in the past. Maybe they're present in your math class, right? But they're the number written in front of either a reactant or a product. They're usually whole numbers, and for the purpose of the class, they actually, in fact, are going to always be whole numbers, right? No decimal places for these coefficients in this class. And what they actually do for you guys is that they multiply through to get the amount of each atom. And here's kind of a breakdown, right? When it comes to chemical formulas, guys, and looking at these different formulas over the last several months here, we've introduced and obviously talked about superscripts and subscripts, right? So when we look at all of these, here are the different, essentially, locations that you can find all of these different things here, right? So a coefficient is going to be the number in front. As we know, the superscript is going to be the number in the upper right, representing the charge. And then, of course, the subscript, the thing we've worked with a lot recently, is going to be that number in the bottom right-hand corner, representing the number of atoms in the formula. So, for example, if we've got this example here, this is a very, very basic example, right? Nothing actually legitimate here, right? We've got all these different pieces here. We've got a big 2 out in front, a 2 plus in the upper right, and a 2 in the bottom right, okay? Well, all of these are going to be representative of these 3 different things. The superscript in the upper right, the subscript in the bottom right, and again, these 2 are essentially review pieces, right? We've talked about superscripts, we've talked about subscript. But the last introductory piece here is this idea of the coefficient. And this coefficient here, guys, is going to be the driving force for what we talk about next class when we start to do what's known as balancing equations, okay? I'll see you guys then. Have a good rest of your day.